Hi, it's me. I just wanted to do something a little bit different today because the next unit is going to be starting up now, the final unit for the class, and that's going to be doing trigonometry. And trigonometry is actually fairly straightforward because you've done a lot of this work before in the past, and it's basically the study of triangles, trigonometry, uh, triangle measurement, and that's where the basis of this is from. I'm going to go through a quick I don't know if I'd call it a summary or an overview of this, but just to give you some relationships that you would be wanting to remember when you talk about trigonometry. The first one is the idea that angles have relationships, all right, with each other and with the sides of a triangle. So if I have a triangle that looks like this, I'm going to change it a little bit. I'm going to make that maybe like a green exterior with a yellow interior just to keep things interesting. All right, so let's talk about angles. And angles are the interior measurements, and you're all aware of those, having dealt with them in the past. So you've got angle here and angle here. And in this case, it's a right angle, but it's a third angle here. All right, so I'm going to give them letters because that helps us to identify what these are. A, B, and C are angles. And for every angle that I have, I also have, and obviously this is a right triangle, I'm going to have an adjacent side and an opposite side and a hypotenuse. Now, when you talk about the hypotenuse, this is constant. A hypotenuse is a hypotenuse is a hypotenuse. Always. There's an absolute thing to that. It's an absolute quality. A hypotenuse is the longest side of a right triangle, if you remember what that was like. And so what you're ending up with is the other two sides and what they are in relation to a given angle. So if I'm looking at angle, say A, for example, okay, I'm going to be able to draw an arrow across to this side here and call it the opposite of angle A. It's the side opposite to angle A. All right. But if I look here, I've got what we call the adjacent side, ADJ, AC, E, and T. Adjacent angles and opposite angles in relation to this one, okay? But it won't always be the case that I'm talking about this one. I might be talking about the other one. So I need to talk about what happens here because, oh, and by the way, when I talk about this, this is still going to be the hypotenuse no matter what I do. Okay, so adjacent, opposite, hypotenuse. Hypotenuse is hypotenuse is hypotenuse. It doesn't matter who I'm referring to. So here I've got the same thing except it switches because here my opposite side will be this side here. So this is my opposite in relation to that angle. That line is way too thick. Let me change that down. And here, what is my adjacent side would be the one closest to me without being the hypotenuse. That's my new adjacent. Okay, and once again, hypotenuse stays hypotenuse. So these are the relationships that you want to remember. And when you have trigonometry and you have these sides, there's relationships of sides to other sides. So there's ratios involved. And so I'm going to write down that word because ratios are the lifeblood of this whole idea. Okay, and so if I were to take this and work it out, just freehanding it. Okay, if I have this here, a given angle, I've got an opposite and I've got an adjacent, and I've got a hypotenuse. And wherever angle I'm at, it will determine what my opposite and adjacent angles sides are. Okay. Now, if I take a basic triangle, for example, if I were to do something like this, I'm just going to create my basic everyday triangle, plain vanilla, nothing fancy about it. So I'm going to do this one again. Okay. But I do like to fill it in, so I'm going to fill it in with, I guess, will that work? Let's see. Okay, that's a little bit better. All right. And um, the same thing is going to apply here as well. So if I look at this triangle, and suppose I give it measurements. Suppose I say that this has got a length of 3, and this has got a length of 4, and I would want to determine the length of this long side here, the hypotenuse here, because this is a right triangle. That would require that I remember Pythagorean theorem. And Pythagorean theorem, if you remember back in the day, says that a squared plus b squared is equal to c squared. All of that is another way of saying that if I square this side, and I square that side, I'll get the square of the third side. All right, so that's what's going to end up being the case here. So if I put a 3 here and a 4 here, I will get the square of the hypotenuse. That's going to become 9 and 16, and that tells me I'm going to get 25. C squared is 25, and based on what we've done in the past, C is equal to 5, which is correct. That is exactly what that is. So C being equal to 5 is my relationship. Now, once I've got that, I need to pick an angle to reference. So I'm going to reference this angle here. I'm going to call that angle A. And if I look at my opposite to my adjacent, I've got a ratio of 3 to 4. All right, the ratio of my opposite to my adjacent, because ratios are another way of saying fractions, is 3 to 4. So that would be my ratio for that. And there's a name for that ratio. Okay, we don't call it that. We call it something else. And that something else, in this case, is tangent. Okay, so tangent is the opposite to the adjacent. But there's other relationships here because I don't have to also think of that. I can think of the opposite to the hypotenuse. And if I think of the opposite to the hypotenuse, then I've got a different ratio. I've got 3 to 5. And that relationship has a name too. It's called the sine. Okay? My sine is my relationship. And then the third relationship I could have, I'm going to bring it up here, is my opposite to, no, my adjacent to my hypotenuse. Right? Just like the opposite and hypotenuse, I have adjacent to hypotenuse. And if I do that, I'm going to have the adjacent being ratioed with the hypotenuse, which would give me a 4 out of 5. And that too has a name. That is called the cosine. Okay, so when I talk about this, I say the ratio of, say, 4 to 5 is my cosine of this angle. The cosine of A is 4 to 5. All right, the tangent of A is 3 to 4. The sine of A is 3 to 5. That's how we read this here. All right, but that's only for here. If I were to do it from here, that would be a different ratio. That would be something else. So I'm going to change the color here. So this would be angle B. And you'll see that I have an opposite and I have a hypotenuse. That would be sine, opposite hypotenuse. The sine of B would be 4 to 5. Adjacent to hypotenuse would be 3 to 5. The cosine of B would be 3 to 5. And you can see that's the opposite here of those relationships. And the tangent would be the opposite in relation to the adjacent. So instead of being 3 to 4, it'd be 4 to 3. So I'm going to summarize all these in a new page. Okay, and remember that I'm going to talk about the sine. Oh, wrong color for that. Let me change it to red. The sine of an angle is equal to the opposite divided by the adjacent, that ratio. Okay, and then we have the cosine of an angle being the adjacent. No, wait, stop. Okay, so if I come here, I'm going to summarize my relationships. I have the sine of an angle would be the opposite to the hypotenuse, that ratio, and that would take care of that. Okay, the next one would be the cosine. The cosine of any angle. Okay, and we're just going to focus on the first 3 letters to summarize, to abbreviate them. So we're going to say cosine of an angle would be the adjacent to the hypotenuse. And then if I talk about the tangent of a given angle, okay, and again, just the first 3 letters is enough, that would be the opposite over the adjacent. But you could also think of it in a different way. You could also think of it as the sine divided by the cosine. And I'll tell you why if I extend the page. And that's because if I take the opposite over the hypotenuse and I divide it by the adjacent over the hypotenuse. Okay, well, basic math theory tells us that when you have this kind of structure, the denominators cancel out, but I'm going to do it explicitly so you can see it. I'm just going to go with letters on top, though. The opposite over the hypotenuse divided by the adjacent over the hypotenuse would be the same thing as the opposite over the hypotenuse multiplying with the hypotenuse over the adjacent, right? Keep flip, divide fractions, and they're going to cancel out. You're going to get opposite over adjacent, which is tangent. That's why that's the case with this relationship here. So you can think of it in either way, and sometimes it's better to think of it this way, and sometimes it's better just to think of it this way, right? Whichever works for you in a given situation. All right. So for an example, if I look at a triangle, I'm just going to draw a freehand triangle here, and we're assuming right angles for this. And I'm going to throw some numbers here. I'm going to do a 5 and a 12 and a 13. Okay, and say I want to get the sine of this angle. If I have the sine of this angle, I need to remember that the sine is equal to the opposite over the hypotenuse. So I would know to look at the opposite to A, which is 12, and the hypotenuse to A, which is 13, and I know then my sine is 12 over 13. It's as simple as that. Okay, the cosine, I would do the same thing, but except it would be the adjacent over the hypotenuse, in which case this would be 5 over 13. And the tangent would be the opposite 12 over the adjacent 5, so 12 over 5. That's all you have to worry about. And just remember that hypotenuse is never adjacent, it's always hypotenuse, because people sometimes make a mistake. The way to remember these relationships is a very, very well-known mnemonic, SOHCAHTOA. SOHCAHTOA breaks down to the three relationships: sine, opposite over hypotenuse; cosine, adjacent over hypotenuse; tangent, opposite over adjacent. SOHCAHTOA. And you can think of ways to remember this by making a little sentence like, some old horses came around hills to own apples, or whatever works for you. SOHCAHTOA is your relationship here. And if you remember that, that should help you get through the right triangle trigonometry piece of the homework that's open right now. All right, what else can we think about with this? There are inverse relationships, like there's the opposite, the reverse of sine would be hypotenuse over opposite. We call that cosecant. I don't know if that's necessary yet. I'm going to take a look and see if that's true. Okay, if we need to do that. But once you've gotten the hang of that, everything should come easily. And what's going to happen, generally speaking, is they're going to give you a question that involves you looking for one of these three given an angle, right? If we had two sides of a triangle, we're looking for the third side, that's easy. We can just do Pythagorean theorem, right? But if we have an angle that we're looking for, so say I have, say, I don't know, 25 degrees, right? And I'm given, say, 100, right? And I'm looking for this, you would have to think about what parts of the triangle these are, all right, in relation to this angle. In this case, that would be the opposite side to the adjacent side. And that means you would look at the relationships in SOHCAHTOA to help you determine which function, which trig ratio you would need here. In this case, you have an opposite. You're looking for an adjacent. An opposite and adjacent are owned by tangent, right? So you would say the tangent of 25 is equal to x over 100, and then you would just solve by cross multiply. All right, but they may not be what they're looking for. They may be asking for the adjacent side, in which case it would be changed around. So it would depend on the problem that you're given. Another thing you might be working for is they give you an angle here, and they're asking you to find the length here. Okay, but that means you need one of these two, right? So if I did, I don't know, 15 degrees maybe, and they may give me this one. They may give me this number to be at 100 again, right? And you would have to, again, look at the relationship. This is the adjacent to 15. This is the hypotenuse that we're looking for. And if you remember SOHCAHTOA, the adjacent to the hypotenuse is owned by cosine, right? So that's my relationship I would need here. So I would have to do the cosine of 15 degrees is equal to the adjacent, which is 100, over the x. And again, I can cross multiply to solve this. Okay, it's super easy to do, but you got to remember a couple of things, and that's going to involve the calculator. So let me bring that up. Okay, now I have my calculator here, and the first thing you're going to want to do, if you have this calculator, or if you have any other kind of calculator, you want to make sure that your mode is correct. So the first thing you're going to want to do is go down to radians, and you see how radians is highlighted? You want to go over to degrees and hit enter, and that'll highlight degrees, because otherwise you'll get what we call radian mode, which is not what you want to do with these problems. You always want to use degrees here. Right? That's the first thing. And then you're going to want to solve this, for example. So I'm going to solve that particular problem by working out the cross multiplication and seeing what I would have to do. So the first thing I'm going to do is take this and solve. And this is easy. I can just swap places and I'll get my answer. So you can verify on your own. X is equal to 100 divided by not 15. The cosine of 15 degrees is your answer. And so I would need to go here and do exactly what you hear here. So 100 divided by the cosine of 15 degrees, not 15. All right. And sometimes your calculator will let you do cosine of an angle. Sometimes it'll let you do the angle, then the cosine. It depends on your calculator. But this is how this calculator does it. And I get an answer of 103. Okay, so 103 is what here? 103 is my hypotenuse. All right, so I'm going to put that in blue, I guess. One, or black, 103, right? 103 what? 0.52, 53? 0.53. We'll leave it at 53. Okay, and now at this point, I could use Pythagorean theorem. I could actually use Pythagorean theorem to get this remaining side. Okay, but maybe I want to use the trig relationships to solve it. So I'm going to do that instead. And that's going to require that I think about what this is in relation to the 15. This is the opposite. Okay, so whatever I do, I'm looking for the opposite, and I am given either the adjacent or I figured out the hypotenuse, but I'm going to use the adjacent, which was 100. And the opposite over the adjacent is tangent. So I would have to look for the tangent of 15 degrees is equal to the not x, maybe I should use y over 100, and that means that I would have to solve for that in this case too, and that would be, let me bring it in so you can see it. Okay, bring it over this side. 100 tangent of 15. Notice I didn't put any symbol there because it knows that I want to multiply because there's no other symbol in between, and I'm going to get 26.79. So that's what this measurement is. This is 26.79. Now, just as an experiment, I'm going to square this value, and I'm going to square that, and see if I get this. All right, so calculator again. I'm going to square that, right? That's a squared, and then I'm going to do b squared, and I'm going to hit enter, and I get this. I will take the square root of that, and I'm going to do it the longer way so you can see that I'm doing it that way. And you're going to see that I get the 103.53. It's the exact same value we had before. Pythagorean theorem and the trig did agree with each other. But again, usually when you have trig, you're going to end up with a problem where you have one side given to you and an angle. And then you have to work out the relationships between them. All right, so I hope this helps. I'm going to come up with a second video about two special triangles that you really, really want to get to know really well. Okay, that's coming up next.